Today we're going to look at our Advanced Algebra New Georgia Standards Data and Statistical Reasoning Standard 2.1. Okay, so let's go ahead and look at some of the concepts there. First, a few definitions. A sample survey informally can be a poll or interview that's sent out to gather information. Okay, so we just want to know what people think about something. You're going to send out a survey. Okay, so that's just generally the definition of that. There's more details we'll talk about here in a minute. An observational study is where observations are made without manipulation in order to gather information. So you're literally just observing, and you're not trying to change anything through your own manipulation. Okay, it doesn't necessarily have to be back in the past. It could just be watching something currently happen, but that's an observational study. Again, the key is without manipulation. An experiment is observations are made and you're using manipulation. You're trying to see if a particular treatment can cause things. Okay, so you are behind the scenes changing variables and seeing what the results of those changes are. Okay, so very similar to observational study, but you're more in control of this one. Here's an additional note on it. Observational studies can imply association, whereas experiments can imply cause and effect. So again, it's very difficult to say through observation only that something is causing something, but when you manipulate the variables, it can more strongly imply that. All right, random is very important in all three. In each case, it's important to be random. Everybody gets an equal chance. Okay, you don't want to put your own biases into it. You want everybody to have an equal chance. A computer to pick it, or say getting every 5th or 10th person and so forth would be an example of random. Okay, the purpose again is to eliminate bias, and you can see again that systematic method or just a random number generator on a computer is good to use here. So let's put this in context. You're interested in study habits and Algebra 2 scores. Okay, so here, a sample survey could be you just randomly select, again, random is important, 100 students and ask them how much they study. Okay, you want to start gathering information. That's what a survey is for. You are gathering information. Random is important, even when you're gathering information, because you don't want to be subject to a particular group of people. You don't want the group that you survey be particularly strong in one area. Okay. In this situation, observational study could be you can gather information about randomly selected students and their login amounts in study labs versus how they performed on tests later that week. Okay, you didn't cause them to go in the study lab. You didn't ask them to. You didn't ask people not to. You just took that information that was already there, or that is being compiled without you being behind the scenes, and you observe it. An experiment could be similar. You can have two different groups. Again, randomly select them. One group, you have go to the study lab for 2 hours. The other group doesn't. And then you can compare the scores. Okay, so there you're behind the scenes manipulating it. In this situation, random is important if, and again, for example, let's say that you chose a group, you handpicked them. And in so doing, you inadvertently chose a very strong group for one of the groups. Okay, so one of your groups was just naturally good. They perhaps independent of studying, they're going to do better generally because they're just naturally better. And they're overrepresented in the group. That can confound or sway the results. Okay, so when you randomly choose them, it helps eliminate that unconscious bias. Here's part of the standard. It says to recognize the purposes of and differences among sample surveys, experiments, and observational studies, and explain how randomization relates to each. Okay, so you might want to read that and make sure you can answer that. What are the purposes of all three? How are they different? And how is random important in all those? Another concept is primary data versus secondary data. Primary data you gather yourself. Secondary data you get externally, you just get somewhere else. And when comparing the two, primary data is generally more authentic, up-to-date, reliable, and specific to what you need. Okay, you gathered it yourself, so If you're interested in something, you probably have just gathered it. You know it's what you need because you did it yourself. Again, we don't know any unconscious biases that may have played a role there for somebody else. You don't know how they gathered the data, but you know how you gathered it. On the flip side, primary can be more expensive and time consuming. Okay, so secondary sometimes can be just a simple internet search if you have a reliable source. Very cheap, but that's the difference there. Okay, so the second part of that standard says this: distinguish between primary and secondary data and how it affects the types of conclusions that can be drawn. So primary you get yourself, secondary you get externally, and the types of conclusions, well, again, you have to be aware that primary data can be more up-to-date, more authentic, more reliable, but also could be more time-consuming and more expensive. So for what you're trying to figure out, is it worth it to get the primary data?